Hello and welcome back to this video series on pandas in Python. In this video, we're going to be covering Chapter 7 of the textbook I've written out for this video series at pandas.pythonhumanities.com. Chapter 7 is going to cover two different things, the filter function and the query function. A good way to think about these two functions in pandas is as ways to pose questions to your dataset. So you can eliminate things that aren't really relevant to your question and only find things that are. This is really useful for historians or anyone who's just trying to analyze a very large data set or even a relatively small data set like this Titanic one that we're going to be working with in this video. So as always, I've already imported pandas, loaded up the data frame, and printed it off here so you can kind of see it. This is the one we've been working with so far for the past few videos, the Titanic data set. So what I want to introduce you to first in this video is the filter function. A good way to think about the filter function is as kind of another way to narrow down your data set to just the relevant pieces that you really need to look at. So a simple way to think about it is as a way to kind of eliminate superfluous or unnecessary columns. So let's go ahead and do df.filter. So we're going to load up the filter function, and we're going to pass in an argument. This is going to be a list. And this list should correspond to the column name or names that you want to filter down. So in this case, I only want to see the names column, so I can pass in a list with just one index, and that's going to be name. Likewise, though, I can do this exact same thing. I'm going to copy and paste to save some time. I can filter it down by two columns and do age. And so I have name and age. So I can see these two pieces of data in this very large data set and just analyze just those two columns side by side. Likewise, though, I can take this exact same argument, but change the list around a little bit so that age comes first, and I can pass in name as the second argument here, or the second index here, and we now have age as coming first in our pandas data set. So this is really useful for kind of taking a lot of columns. Sometimes you'll have, if you're working with the Spotify data set, thousands of columns. This is a good way to narrow it down just to a single few. Now, once we've got this data set kind of made, or a new data frame made, we can create a new object with it. So let's create an object called newDF and make it equal to this new filtered one. If we print off newDF, we actually have our new data frame printed out, which means it's a new object, which means we can save this as a new CSV file. So imagine if you got a data set from somebody and it had thousands of columns and you really only needed a handful of those. You could create a new data frame really easily and then save that new data frame as a new CSV file, which will be smaller in size and easier to work with. And then you can load it up in Excel should you wish. But filter can do a few other things. Now, there's sometimes better ways to do this in pandas, and we're going to see some of the stuff that we did in the last video kind of reconstructed here, but a little differently. So what we can do is we can say something like df filter, and again, we're going to pass in our name column, just our name column for right now. And we can say dot name, so we're going to index that specific column now. If it contains str.contains, and we can, like we saw in the last video, pass in an argument here. So we're going to only print off a Boolean for true if that column name contains the name contains MISS period. So if it does, it gets a true, and if it doesn't, it gets a false. I know what you're probably thinking, what's the real utility here? Well, this is a pretty good way to use the value counts function that we met a while ago and count up very quickly how often a specific string or piece of data might occur within a given column. So we can see very quickly that we have 182 instances of miss followed by a period occurring in our data set and 709 instances where it does not. So we can really quickly kind of do some quantitative and qualitative analysis of our data relatively quickly. But let's say we wanted to make sure that the data frame column wasn't just kind of a bunch of Booleans. We wanted to actually see the data set as a whole. Well, one of the things that we could do is we could do this exact same thing that we kind of saw before. We can create the data frame, index it, and say we want a df.filter. We're going to filter it down by age and name. Not really necessary for age here. We're going to do it anyway. And like we did above, we're going to make sure that it actually contains the name.str.contains. I'm going to make sure that that contains the string MISS period. And then what we want to do, if we want to say that this new data frame that we're going to show should have that, and if that's equal to true, then populate it down below. And so real quickly, we can filter out our data set to only show the rows where the column of name contains MISS. So if it has that sequence of characters, then print it off, and we can see our data frame now looking like it does here with everything all printed off. So that's one thing that you can actually do. Let's say that you were just interested in kind of not looking at the whole data set. You just wanted to only show the name and the age if the name contains MISS. Well, you can just do something a little similar. You can index the data frame, df.name.str.contain. So we're going to do this almost like backwards from what we did before. If it contains that string and that is equal to true, then what we want to do is we want to filter that result down to just age and name. So we're putting the filter at the end here. So after this condition is met, then we filter down the data set. So this is a way you can kind of do the same thing that we saw above, but keep a filtered version of that data set with filter. So that's the filter function. It has a very narrow usage. I find myself using it when I just need to really quickly kind of look at only a few columns, or really just kind of quickly need to get a quick value count of things. But really the one that you're going to use probably more often is the query function. So the query function, a good way to think about it is as a way to structure a question to a data set. If you're familiar with SQL, then you'll be familiar with query, kind of query strings where you write out a series of commands and the database gives you a set of results based on those commands. So that's going to be how the query function works in Pandas. You can do it by doing df.query, and this is going to take a string. And this is where you're going to have to get used to some SQL kind of commands here. So I'm going to say the column that I want to query, what needs to be in that column. So in this case, it's going to be equal to, and then what it needs to be equal to. So think of this as a command. The place, the condition, and the thing that has to meet that condition. And if all this is true, then you get a result. And the result is that you get a data frame that is much smaller, in this case 491 rows, all the rows where p class was equal to 3. So this is how to really quickly structure a query and get a new data frame based on these results. But query is more powerful than that. We can do df.query, and we can pass in several commands. So p class is equal to 3, and we can use the ampersand. If you're using a Western English keyboard, then it's going to be Shift 7. It might be a little differently on European keyboards, I'm not entirely sure. But we can do an ampersand, and we can add in another condition, if survived is equal to 1. So the Boolean 1 is equal to the individual did survive. So these two conditions have to be met for us to get a result. And we see we've now narrowed our results down to 119 rows. So if we were interested in just seeing who these individuals were that survived, that were in third class, we can grab that answer pretty quickly. Let's add in another condition to, again, narrow our query down further. And again, I'm following along in the textbook. If you get stuck, feel free to pause it, go read the textbook, and follow along there as well. We're going to add in another condition here, if age is greater than 40. And once we do that, we notice that we have now only 3 rows. So this is pretty interesting. We've gotten a very specific question, and we've gotten a very specific result. We can also add in, and I want to make very clear, I'm about to show you a mistake, so be wary kind of going forward right now. What we're going to do is we're going to add in another condition. We're going to say or. And or, if you remember from the last video, is the straight up and down slash, which if you're using, again, a English American keyboard, it's going to be just above the enter button or the return button. So what we can do now is we can say, or age is less than 10. So what we're interested in is any of these conditions were met, or age was less than 10. And if we print this off, we're going to start to notice some problems. What do we notice? Well, P class 2, this isn't right. This should not be there. Well, why is it there? Well, it's because it met the or condition here. So the final or condition was or the age is less than 10. And this does in fact meet that. So what we have to think about here is something we might have forgotten about from grade school mathematics, which is the order of operations. Whenever you're structuring conditions in a programming language, it is important to wrap conditions in a parentheses should they need to be together. So if I want to grab any instance of p class is equal to 3, survived is equal to 1, and an age where it's either greater than 40 or less than 10, I need to structure the age conditions within parentheses after the ampersand. If I do that, and I execute it, we now see that our results are what we expect. Everyone is third class, everyone survived, and everyone is either over the age of 40 or under the age of 10. And so I've gotten now a correct result from my very, very specific question. And that's how we kind of use the query function to structure questions, pose it to the data set, and get a result. And if you get really good with working with the query and the filter functions, you're going to find that your time with pandas is a lot easier and you're able to do things more efficiently. That's going to be it for this video. Thank you for listening. If you've gotten a lot out of this video and you get a lot out of this channel, please do consider supporting it via either Patreon or via the join button down below on the channel, where you can join the channel and contribute monetarily to keep everything on this channel free for everyone.